Hello and welcome again to Haybridge Maths Department Year 2 Pure Chapter 3 series, where today we're going to be looking at recurrence relations and how they work. Okay, so here is a recurrence relation, this very simple one. What recurrence relations are all about is about putting back in what you get out as a looping effect that we have when we do a recurrence relation. We get an answer out, we see what it is, we plug it back in. We get an answer out, we see what it is, we plug it back in, and we repeat and we repeat and we repeat until we've done enough iterations to for whatever the question is asking for us. So here we've got un plus 1 is 2un plus 3, where u1 is 6. So what does all this notation mean? Well, it means the first term in our sequence is 6. So we can write this down. We can say u1 is 6. Now, how do we get u2? Well, probably find them on a nice desert island where we don't have to pay any taxes. Sorry. But u2 is also the second term where in the sequence. And the way that we get that is we do 2 lots of 6, because that's the one that we had before, add 3. So you do 2 lots of 6, which is 12 plus 3, which is 15. And then we take this 15, and to get u3, we put it back in to here. So we do 2 lots of 15, which is 30, plus 3, which is 33. And we get u4 by doing 2 lots of 33 plus 3, which is 69. So that's a very simple recurrence relationship. Let's have a look at another where we can see how it works again. And this is from example 9 from the textbook. We've taken that and I will show you how it works here. So if we have u1 equal to 7, then u2 is a terrible band full of aging dinosaur rock stars, but u2 is also 7 plus 4, which equals 11. u3 is 11 plus 4, which is 15. u4, and it wants the first 4 terms in this. We've already got u1, so we've got u2, u3. Now we want u4 is going to be 15 plus 4. So it's all about whatever you get back at, whatever you get out, you shove it back into it. Get something out, plonk it back in, and just cycle round and cycle round for however many iterations. Okay, if you haven't done so already, make sure you pause, make notes, and then if you could have a go at this example. Oh, I've just realised I haven't done 15 plus 4. I forgot to actually write that was 19. Whoops. So now pause and make notes and then have a go at this example here. Okay, so you should see, compared to this, it's very similar, but our starting value is 5 instead of 7. So you should have had exactly the same sequence, but you started with a different value. So u1 was 5, u2 best days are well behind them, but u2 is also 5 plus 4, which is 9. u3 is 9 plus 4, which is 13, and U4 is 13 plus 4, which is 17. Earlier on I said that U2's best days were behind them. I'm very dubious to say whether they did have any best days. But anyway, there's your first 4 terms of a sequence. If we look back to the one before, very similar. It's a very simple arithmetic sequence in both of them. Let's have a look at a much more complicated example. Let's have a look at this example here, where there's a lot more going on. It's the first 2 examples that we did there, very, very basic. I hope at least here this is a lot more tricky. We've got a lot more going on with this example. So in this example, we've got our first term is P, and the next term is generated by squaring the previous term and taking away 1. So in part A, they want us to work out what A3 is equal to. Here we've used A instead of U. That's not a problem, everything's fine with that, but we've got a little bit of work to do in each part of these questions to work it all out. So let's get cracking with part A. So we've said A1 is P. A2 is going to be, well, we're going to take the P and we're going to put it in here. So we're going to get P squared, take away 1. And then we're going to take the P squared, take away 1, and we're going to plug it into, if you can just about see it, our formula up there. So we're going to do P squared minus 1 squared minus 1. Now, if you look back at the question, then we see that what we've got there, we've got a bit of work to do with our algebra about expanding out this bracket here before we get to the p to the 4 minus 2p squared. So if I square out p squared minus 1, I'm going to get p to the 4 minus 2p squared plus 1, and then we've got this take away 1 here, so we'll put that back in, and of course the plus 1 and the minus 1 cancel out, and we have p to the 4 minus 2p squared, and we've got what we were looking for, which this would work. There you go. Right, given part B, given that A2 equals 0, find the value of P. So we have to use in B, even though they've got us to work out A3, we're going to have to use this here. This A2 is P squared minus 1. So if we know that A2 equals 0, then this implies that P squared minus 1 equals 0. Now you can take over and square root. I much prefer difference of 2 squares. Dots p minus 1, p plus 1 equals 0. So p equals 1 or p equals minus 1. But if you look back at the question, hopefully, no, you're not. So if we move this here, no, you're going to move. So if we move this, sorry about this, folks. If we move this, why are you being so difficult? Page up. Hey, we've got something there. If you looked there, it said P is less than 0. So if P is less than 0, then P has to be, so P is less than 0, so P equals minus 1. Okay, let's have another look at this. Let's come on, move back up. You're still being very awkward, aren't you? Sorry, yeah, here we go. Okay, in part C, we've got to find the sum of the first 200 terms. So we're going to go R is 1 to 200 of AR. So it's a complete, well, not a completely different question, but we're having to do look at it in a different way. So what does it mean if we're going between R is 1 all the way up to 200 of AR? Well, what we're going to do is, we said that P was -1 and A1 was P, so we've got -1. We know that A2 was 0, so we've got -1 plus 0. And then if we put 0 into our formula here, well, we've got, sorry, if we put it into the formula here, I should say, we've got 0 squared, take away 1, which is going to be -1. So you've got -1, and then if you put -1 into the sequence, you're going to get 0. So we get another 0. And take away 1 plus 0. It's just going to keep on bouncing backwards and forwards like this all the way up. So we're going to keep on going, and you're going to get a -1 plus a 0 at the end. Now, if we're looking at 200 lots of these, if we consider these in pairs, you've got a -1 there, a -1 there, a -1 there, and you've got all these -1s, and in fact you've got 100 lots of these -1s, so you've got 100 times -1, which is -100. Nice. So after you sum all of it up, you get to -100. Okay, finally, write down the value of A199. So in this, in 199, well, if we think about this, our terms are going between -1 and 0. First term, -1. Second term, 0. Third term, -1. Fourth term, 0. So what's happening is it's bouncing backwards and forwards. And if the number of the term is odd, then it's going to be -1. If it is even, it's 0. 199, this is odd, so that's going to be -1. Bit of a weird question, quite challenging compared to the previous example, but you need to be aware of how to do questions like that. Okay, rather short lesson today, but you do need to be able to use this. It is something that is important. So could you now, if you haven't done so already, pause, go through, make all the notes, and then have a go at exercise 3G.